video, you will learn how to find the volume of composite solids. Make sure you are writing these examples down in your notes as you follow along. Our first example is a composite solid made up of two different rectangular prisms. We are going to find the volume of each one. Rectangular prism number 1, we are going to use as the one here on the left. We'll call this number 1 and we'll call this little one number 2. To find the volume of a rectangular prism, the formula is length times width times height. So we'll first write down the formula. Then we'll plug in the values for the length, width, and height. In rectangular prism number 1, the length of the prism is 5 inches. If you look at the bottom, 9 inches represents the length of both rectangular prisms combined. So we actually need to look up at the top to get the 5 inches, which is the length of rectangular prism number 1. The width of rectangular prism number 1 is going to be 6 inches. You can see that this width is the same as this width over here. You can also look up here to find 6 inches as the width. And finally the height, which is 18 inches. If you multiply 5 times 6 times 18, you will get 540 inches cubed, since we are talking about volume. Moving on to rectangular prism number 2, we are going to do the same thing, length times width times height. The length of rectangular prism number 2 is 4 inches. The width is again 6 inches, as it's the same width as the first rectangle, and the height here is 7 inches. When you multiply 4 times 6 times 7, you get 168 inches cubed. And then for our final answer, we need to find the total of both combined. So we will add 540 plus 168, which gives us a total of 708 inches cubed. Moving on to example number 2, here we have a composite solid made up of a rectangular prism on the bottom and a trapezoidal prism on the top. Let's start with a rectangular prism. Again, we know that the formula for finding the volume of a rectangular prism is length times width times height. In this example, the length is 5 centimeters, the width is 10 centimeters, and the height is 3 centimeters. So we're going to multiply 5 times 10 times 3, which gives us a total volume for the rectangular prism of 150 centimeters cubed. Now for our trapezoidal prism, we will use that other formula that we discussed yesterday. Volume equals area of the base times the width. In this case, we are talking about a trapezoidal prism. That is our base. So we need to replace the capital B with the area of a trapezoid formula, because we're going to find the area of that trapezoid and then multiply the whole thing by the width of the entire prism, which is 10, to get the volume of the trapezoidal prism. So first thing I'm going to do is replace B, the capital B, with the trapezoid formula for area. So that's 1/2 height, base 1 plus base 2. All of this replaces the capital B. We cannot forget to multiply that by W. If we don't multiply by the width, then all we did was find the area of a trapezoid, and that is not going to obviously be volume, it is just area. We want the volume, so we have to remember to multiply by the width, which is 10. Okay, so looking at our trapezoid, we have 1/2 times the height. The height here is 2 centimeters. Base 1 is also 2 centimeters, and base 2 is 5 centimeters. So that's 2 plus 5, and then the entire trapezoid multiplied by 10 to get the volume. All right, so half of 2 is 1, so that's 1. times 2 plus 5, which is 7, times 10, 1 times 10 times 7 is 70 centimeters cubed for our total volume of the trapezoidal prism. And for the combined solid together, we will add 150 plus 70, which will give us 220 centimeters cubed for our total volume for this composite solid. Let's take a look at one more example. This one is a little bit different than the other ones, as we don't have two shapes attached to each other, but we have one shape with another shape cut out of the center of it as a hole on the inside. So we're going to first look at what shapes we have. We have two triangular prisms. So for both of these, we're going to use this V equals capital B times W formula. And since they're both triangular prisms, the area of the base, or the capital B, for both of these, we will replace with the triangle formula, because we're going to find the area of each triangle and then multiply by the width for the volume. So the area of a triangle is 1/2 times base times height, and then again we need to remember to multiply that times the width. Otherwise, all we have done is found the area of a triangle. So same thing for the second shape, because it's another triangular prism as well. Okay, so let's first start with the outer one, the bigger triangular prism. We have 1/2 times the base. The base of this triangular prism, remember, the base of the shape is the triangle, okay? It's not sitting on the triangle, but that doesn't mean that the base is not the triangle. Remember that the base is the shape that gives the figure its name. So if it's a triangular prism, the base is a triangle. Yes, it's sitting on the rectangle, but that does not make it the base. The base is always the triangle in a triangular prism, whether it's sitting on it or not. Okay, so area of this triangle, 1/2 times the base of this triangle, which is 9, times the height of this triangle, which we actually have to look all the way back here for, is 6, times the width of the prism, which is 5. If I multiply 1/2 times 9 times 6 times 5, I would get 135 centimeters cubed for the outside triangular prism, or the larger the larger triangular prism. For our smaller inner triangular prism, we're going to do the same thing. Again, it's a triangular prism because the base is a triangle. That's what gives it its name. So we are going to do 1/2 times base times height. That's going to give us the area of this triangle. And then we're going to multiply it by the width again to get the volume. So 1/2 times the base of that triangle, which is 3, times the height of that triangle, which is 2, times the width of the entire prism, which is 5 again. It's kind of hard to tell, but as generally speaking, the hole is going to go all the way through from front to back. So it's going to be the same width for the inner prism and the outer prism. Multiplying 1/2 times 3 times 2 times 5 will give us 15 centimeters cubed. And for our total, this one is actually a little bit different. Since we are having a hole cut out of the middle, we are going to, instead of add these two, we are going to subtract them to find the difference between them, leaving 120 centimeters cubed as our final volume for the space around the hole that was cut out. Okay, so a couple final things to remember here. When it is a rectangular prism, we always use length times width times height. For any other prism, we use this formula, B equals BW, where B is the area of the base. So you're going to be responsible for looking at the figure, figuring out what type of shape it is, and figuring out, okay, well, if it's a triangular prism, the base is a triangle, and I therefore need to replace the capital B with the area of a triangle formula. So we need to be very, very careful about observing the figure and determining what formulas are going to go into this formula. We have really only two options: the triangle formula and the trapezoid formula, which is both are on your formula sheet.